Myself, Dr. N. Srinivas, Professor of EC Department, Reddy Institute of Technology and Management. Today, I am here to discuss the concept is what is amplitude modulation. Okay, so we especially we discuss what is definition of the amplitude modulation and time domain equation for amplitude modulation and frequency domain description for amplitude modulation. So, what is the modulation, demodulation techniques of AM? So, these are the things we are going to discuss very briefly. Okay, in the last lecture, we have already discussed significance of modulations. Now, today, we are discussing briefly about amplitude modulation. So, here you can see there are basic modulation types. Continuous wave modulation, and especially we can call it as amplitude modulation and angle modulation. These are the classifications of continuous wave modulation and pulse modulations, digital pulse modulations. So here PCM, DPCM, DM and ADM are the different modulation techniques will come under these digital pulse modulation schemes. And analog pulse modulation schemes are PAM, PWM, PPM. So here in analog communications, especially we are discussing amplitude modulation and angle modulation. In amplitude modulation, we have DSBFC, that is nothing but double sideband with the full carrier, and DSBSC, that is nothing but double sideband with the suppressed carrier, and SSBSC, that is a single sideband with a suppressed carrier, and VSB is a vestigial sideband modulation. So every modulation is having its own importance. So why we are going for amplitude modulation and from DSBFC to DSBSC? So why we are going from DSBSC to SSBSC? Then again why we are going for VSB from SSBSC. So every modulation scheme has its own importance. So in this lecture, we study double sideband with the full carrier. This is also called as amplitude modulation. Here you can see amplitude modulation and demodulation. So here source, we are taking source. So that source contains that is nothing but transmitter. So transmitter consists of a modulator. So next after transmitter, again our signal, modulated signal will be transmitted to through channel. So here channel is there and the sync is our destination, that is nothing but receiver. So receiver consists of demodulator. So modulator block is there in the transmitter side and demodulator block is there in the receiver side. So here before modulation, the signal is said to be baseband signal. So here baseband signal means the signal which is having significant frequency but it is low frequency. So low and significant frequency is called a baseband signal. So after modulation, the signal is a high frequency signal because basic property of modulation is we are converting low frequency to high frequency. So here high frequency signal is coming after modulation process and we are transmitting this high frequency signal to channel. So that signal is said to be band pass signal. So here with the carrier frequencies FC and this is also called as modulated signal. So before modulation, signal is baseband signal or modulating signal. After modulation, the signal is said to be band pass signal or modulated signal. Then what is the function of a demodulator? So demodulator input is a modulated signal and a demodulator output is a demodulating signal, means demodulated signal means a message signal or original signal or modulating signal. So here the process of converting modulating to modulated, that is the modulator role, and the process of modulated signal to modulating signal, that is nothing but a demodulation process. Okay, so here this is a complete discussion about a modulator and a demodulator and a channel. So here voice signal generally 30 Hz to 3400 Hz is the voice signal frequency, and especially in cell phone, we use carrier frequency is 900 or 1800 megahertz. So carrier frequency is always carrying the message signal. So for the long distance communications. So this is about modulation and demodulation process. Now we are seeing, right, you can see this is a modulating signal and this is a demodulated signal. Sorry, modulated signal. So modulated signal, and we are discussing about AM modulation. So amplitude modulation. So this is the amplitude modulated signal. Then when this amplitude modulated signal passing through demodulator, so again we are getting the same signal back here at the receiver side, means output of demodulator. So you can see here same signal you are getting, that is also a low frequency signal. Now so how can we define amplitude modulation? So amplitude modulation can be defined as it is a process in which any that the amplitude of the carrier signal is varied linearly in accordance with the amplitude of the message signal. So that is called amplitude modulation. So here we can see carrier frequencies ranges from several kilohertz to several megahertz. That is, the carrier frequency is very high, and the modulating signal frequency ranges from several hertz to kilohertz only. So this is up to megahertz. So just now we have seen cell phone case 900 or 1800 megahertz is the carrier frequency, and voice signal frequency is just 10 kilohertz, 15 kilohertz. So this is about amplitude modulation definition. So what is the amplitude modulation? So amplitude of the carrier wave is varied linearly in accordance with the amplitude of the message signal. So this is called amplitude modulation. Now we can see what is the mathematical expression in time domain for AM signal. So you can see here S of t is denoting modulated signal. Here AC into 1 plus K. K is the amplitude sensitivity. That units are per volt. That is voltage inverse into M of t. So M of t is our message signal or modulating signal, and this M of t, we don't know how many frequency components are there. So let us consider this M of t is a multi-tone. So into cos omega ct. So this is a time domain equation for multi-tone AM signal. So this signal we are doing, this is the modulated signal. So let us take this is the modulated signal waveform, and this is the mathematical expression. When you are demodulating this signal, so we have to get our original signal, modulating signal. So here I am showing you this is the modulated signal, this is the modulating signal, this is the carrier signal. So carrier signal is AC cos omega ct. So this is a high frequency carrier, that is where the cycles are very close to each other, and the M of t is a low frequency signal, this is a modulating signal, and here I am showing wide cycle, means time duration is the time period is very high, so frequency is very less. So this is the signal mathematical expression of AM. So here we are seeing carrier signal, mathematical expression and waveform, and modulating signal, mathematical notation and waveform, and a mathematical expression for AM signal in fault multitone and also waveform. So here you can see S of t, that is nothing but modulated signal, AM signal. So here we can see what is the maximum and what is the so how the carrier is varying, that is the thing. Envelope AM we are seeing. So what is the AM definition? Amplitude of the carrier signal. So this is the carrier signal. So carrier signal is varying. How it is varying? It is varying amplitude of the modulating signal. So here if you see the envelope of this carrier signal variation is nothing but modulating signal. So this is the modulating signal. It is sitting on the carrier signal so in the form of variations of the amplitude of the carrier signal, and it is carrying. Carrier signal is carrying. What is carrying? It is carrying modulating signal. See, you can see here, this is the modulating signal is sitting on the top of this carrier signal. So carrier signal is carrying the modulating signal. That is why the signal is said to be, C of t is said to be carrier signal. Okay, so here amplitude is nothing but AC into 1 plus k into m of t. So m of t is the modulating signal. Suppose m of t maximum amplitude is am, then what happens? AC into 1 plus k into am is the maximum amplitude. If the m of t is having minus am is the minimum amplitude, then what happens here? AC into 1 plus k, 1 minus. So here 1 minus into 1 minus k into, so that is am. This is the minimum amplitude of the modulated signal, and this is the maximum amplitude of the message signal, modulated signal. So this is the envelope of am and how carrier is carrying the am signal. So here you can see how we are getting this signal. S of t is equal to AC into 1 plus k into m of t into cos 2 pi fct. So this is the modulated signal. So here the diagram showing how we are converting m of t to s of t, how we are getting this s of t, that is the am signal. So here we are having k is the, okay, k is the, so amplification factor. So m of t is multiplied with the k. So here you are getting m of t into k. So again you are having addition, adder is there. So 1 plus k into m of t are getting, 1 plus k into m of t are getting, and again you are multiplying with the AC cos 2 pi fct, means AC cos 2 pi fct into 1 plus k into m of t. So this is nothing but this signal. So this diagram is showing how we are converting m of t to s of t. So this is the am signal. Okay, so how we are deriving this signal expression. So now we can see, so what is m of t signal, what is s of t signal when you are having, okay, so suppose m of t is am cos 2 pi fmt, and what is s of t? S of t is nothing but AC into 1 plus okay, so AC into 1 plus k into, let me take am na, so m of t into cos 2 pi fct. So what is happening here? This is m of t. I am taking cos signal. The Fourier spectrum of cos signal is nothing but we know del of omega minus omega c plus del of omega plus omega c by 2. So you are having two impulse signals. So here one signal that is coming right side of this 0. So this is nothing but del of omega minus omega c upper side band. Sorry, this is a modulating signal, positive side modulating signal, positive side, that is del of omega minus omega c, positive side modulating signal component. And here after modulation, what you are seeing, s of t you are getting. So s of t is consist of carrier signal as well as two side bands are called upper side band, lower side band, and carrier. So that is why this am can also be called as double side band with the full carrier. So at the beginning of this lecture we have seen different modulation schemes under am: double side band with the full carrier, double side band with the suppressed carrier, double side band single sideband with the suppressed carrier, and vestigial sideband modulations. So here I am showing two graphs. One graph is showing modulating signal, that is m of t. Here another graph I am showing here, s of t is the modulated signal. So here the s of t is the modulated signal, consists of two sidebands and carrier with respect when compared to message signal. So from this you can find bandwidth of the modulated signal. So here for example 3500 is the lower sideband, and 4500 is the upper sideband, and 4000 is the carrier frequency. So when we are taking bandwidth calculations, upper sideband minus lower sideband means 4500 minus 3500, so it is giving 1000 edges. 1000 edges is the bandwidth of the modulated signal, AM signal. Suppose it is also in terms of free mathematical expression 2 into FM. So 2 into FM, where FM is the maximum frequency of message signal. Here maximum frequency of message signal is 500. So 2 into 500 is also 1000. So from this equation, you are getting 1000 edges, and from this waveform, you are also getting 1000 edges. So this is the way how we are calculating the bandwidth of the modulated signal. So you can see LSB component is FC minus FM, and USB component is FC plus FM. So in frequency domain, it consists of low sideband or low frequency LSB, so carrier frequency, and also upper sideband frequency is USB. So FC, FC minus FM, FC plus FM. So total 3 components are existing in the modulated signal. So here in this slide, we are discussing how we are calculating the modulation index of AM signal. So we know, as we know, I'm taking M of t is AM cos 2 pi FMT, and C of t is AC cos omega CT. So modulating signal and the carrier signal, and this is the modulated signal. Okay, so modulated signal case, I am taking Ka is 1. Okay, and S of t is equal to AC plus AM cos omega t. I am substituting here M of t and cos omega CT. So from this, you can take AC is the common. So here AC, if you take common, then what happens? So 1 plus AM by AC cos omega t, omega mt, and cos omega CT. So this is the, so what is the mu here? Mu is nothing but AM by AC. So modulation index. So modulation index doesn't have any units because AC is in volts and AM is also in volts. Volts get cancelled, and mu doesn't have any units. So here mu is ranging from 0 less than mu less than or equal to 1. So it will be mu less than 1 or mu equal 1 maximum, or mu greater than 0. Mu will be never negative. So here mu is equal to 0 means no modulation. When mu is equal to 1 means 100% modulation. When mu greater than 1 means over modulation. So here we are classifying our modulation based on the modulation index. So this is the waveform for modulation index when modulation index equal to 1. So you can see this is the variations of the carrier signal, and with respect to amplitude of the message signal, this is mu is equal to 1. So this is the modulation index when mu is equal to 0.05. So in this case, here carrier variations are with respect to amplitude of the message signal. Okay, so here maximum amplitude is 2 volts. This is the modulation index is greater than 1. Greater than 1, let us take mu is equal to 2. So in this case, what is happening here? The this carrier frequency and variations are also coming to the negative side. So this part indicates the V minimum. So this part indicates the V maximum. So here when the modulated is over modulated, then you are getting negative. V minimum is negative and V maximum is V maximum, that is a maximum amplitude. So from this waveform also you can find mu like this. So V max minus V minimum by V max plus V minimum. So this is also a formula for finding the mu value, but here V minimum is negative. So you can rewrite this equation. Mu is equal to V max minus V minimum. So it becomes plus. So V minimum by, so V max minus V minimum is minus now. So minus V minimum. So numerator is positive denominator is negative, definitely it will be greater than 1. So this is the waveform for over modulation, okay, over modulated signal. And also you can see high percentage modulation. So this is nothing but it is important to use a high percentage of modulation as possible while ensuring that over modulation, here k is nothing but mu. So this is mu, when mu greater than 1, so it is the over modulation. So that is the sidebands contain information and have maximum power at 100% modulation. So when mu is equal to 1, you are achieving 100% modulation. So and the total power equation is PT is equal to PC into 1 plus mu square by 2. Okay, so PT is the total transmitted power and C is the carrier power. So this is the equation for finding the total power of a modulated signal. So in this, if you split this equation, so PC plus PC into mu square by 2. And we know already S of T is consisting of carrier as well as lower side band and upper side band. So lower side band and upper side band power is PC into mu square by 2 and the carrier power is PC. So this is the way of finding upper side band and lower side band and carrier power components, carrier components powers. So thank you. And so next class we will be discussing briefly about how we are generating AM signal, also how we are demodulating the AM signal. So thank you very much.